All right. Um. Good day, everyone. We are back and we are up and running again. So today is the day three of the um training that has been organized by Royal Grad Engineering Trainees REnT. So today we are going to talk about the pre-analysis, um building analysis designs. Then we are now going to move into the substructure. Sorry. So we are now going to move into the substructure after that. Then we are now going to explore the design reports and detailing. Okay. So this class is going to be a very short one because these things that are outlined here they require they usually don't take a lot of time. So okay, so they actually take more of your expertise and all that. Okay. So let's jump back straight into our software ProtaStructure. So we are right here. Okay. So in our last class we looked at how we could be able to create a building model just like this one. Okay. So this is actually a two-story building, although we use a different projects for that, but it's pretty much more or less the same procedure to get the same results. Okay. So here we have a two-story building right here. So we are going to be performing analysis and design of this particular structure. Okay. So but before we continue, I would like to explain to us that there is something that we call an advanced classes. So that is organized by REnT. Okay. Royal Grand Engineering Trainings will also organize advanced um, training session. So the knowledge that you're going to be getting from this session is going to be enough for you to at least do some basic modeling. But nevertheless, there are some manual principles and there are some things that has to do with designs that you ought to know as a structural engineer or a structural designer. So in this our advanced classes, we take this time step by step to go in depth to teach you everything that you need to know to become a good structural designer. Okay. So without wasting most of our time, let's be up and running. So when you are finished doing your modeling and analysis, okay, the next thing that is left for you to do is now to perform um when you are finished doing your modeling, rather building modeling, you have finished modeling all the components, all the balconies and all that. We didn't cover that in this particular section. Okay. So the next thing that you need to do after that is to run analysis. After running analysis checks, then you can now um, do a design of your members. That is sizing your members and checking that the reinforcements that are provided are actually good enough and good to go. So simply go to the analysis tab here on your building setup tab on your on your analysis tab. So you get this option that says analysis manager, building analysis, and we have pretty much many options here. Okay, so that's what you are going to be running is a building analysis. So we have this option to run FE floor analysis and foundation analysis and all that. So just simply say building analysis, click on that once. So this building analysis tab is going to show. So here we have the pre-analysis model options, analysis, post-analysis, and reports options here. Okay, but here in the pre-analysis, we are going to come from here first. So we are going to go to the settings center. So simply click on that so that we can see the different settings that we can be able to make. So the first here that we are going to see is the codes. So the code of practice that are going to be used for the analysis and design of this particular structure or for this project. So we have here for our concrete design code, we are using the Eurocode 2. Remember I said that the Eurocode the template that design code template that we chose for this project was the Eurocode. Okay, so but the code that is used for reinforced concrete designs is the Eurocode too. So the Eurocode has up to 10 different codes contained inside that Eurocode. So but the code, the actual code that we are now use for reinforced concrete design in Nigeria is Eurocode 2. So we also use Eurocode 3 for steel design, and Euro code 4 for um design of composite structures and all that. So we also have a different code for wind loading, for timber structures, design of timber structures, and for structures under the force of seismic loading. Okay, so but nevertheless, we are just going to make settings for our concrete structures because that is basically what we have modeled. So just click on that. You have the option to select the code that you're going to be using for your first concrete design. So I don't want to alter anything here. So because we already know that we have to use the Euro code here. So let's just pick the Euro code. So we can change the steel code if you want. You can change that to the BS 5950. We have that here. Okay, yeah. Here is the BS 5950. That's the code that we use in most Nigerian schools for steel designs. But nevertheless, we are going to use the Euro code 3 for our steel design because the BS 5950 and became obsolete as well. So you have the option to change every code that you want here. So, but you're not going to be going to all of that. You also have here for composite structures. Composite structure, that is structures containing concrete members and your steel members. Okay. So then the next basic setting that we are going to check is um lateral drift and bracing. Okay, so in this lateral drift and bracing, it defines the bracing conditions of your beams and walls. So walls and beams and columns in direction one are actually braced by your members in direction two. So the same thing goes for columns and beams in direction two. They are braced by columns and beams in direction one as well. Okay, so unmarked member groups are bracing members. Okay, so here we have the sway amplification coefficients. Okay, this will automatically be calculated after the analysis based on the sway classification of the structure. So if the structure is now classified as sway, so the amplification factor will be greater than 1, and the and all analysis method will be automatically amplified to that value. So you still have the option to check this user defined to define your application factor manually. So but I recommend that you uncheck that so that when you uncheck that, the program by itself uses the correct application coefficient gotten from the analysis for design. So this application, this way classification coefficient is actually used for seismic design purposes um for your buildings when they are going to be subjected to seismic loadings and all that. So we cover that in our advanced classes. Okay. So here we have the lateral drift and bracing. Okay. So here one other thing I would like us to set before we continue is in the unit tab. So go to the unit and format. So we have this option that says displacements. We can change that to millimeters so that the displacement result values is going to be shown in millimeter. That is our bending moments and all that when we are going to be looking at the analytical model of our structure. Okay, so moving on, let's just say okay, that's basically everything that I would be needing to set before our analysis. Then of course we have the option to go further and set the design parameters for our different columns, beams, slabs, foundation, and the way we want the software to um, curtail the reinforcements and all that. So for want of time, we are not going to be going into that right now. This is the ones I've just set is the one that is necessary for our classes right now. Okay, so just say okay when you're done. All right, so we have this. So now go to the loading combinations. In this loading combination, I've already explained this and we have already generated our loadings. Okay, in our previous classes. Okay, but in case if you missed that, just click on this loading generator to down generate different loading parameters for your same different load cases combinations for your structure. Okay, so we have vertical loading combinations and we have horizontal load combinations as well. So I can click on this notional loading if I want to checks for notional loading. Notional loading are just imaginary loadings that are used for analysis purposes. Okay, they take care of unforeseen circumstances during either construction or design. Okay, so I'm going to apply that. So it's a very good thing to apply during your design. So we are not designing for wind. We are not going to be applying this wind loading in our analysis. The reason is because this is a very small structure. Even though we are going to be having some wind effects on that structure, it's going to be very very minimal. And plus, I do not want to add this wind loading here. Nevertheless, there are many considerations that are taken into account in applying your wind loadings. So, but we are going to be explaining that during our advanced classes. Okay. So here we have vertical loadings. Leave that as default. We have many vertical loadings. So these loading combinations helps to check the structure at the worst possible loading combination. It combines maybe live load, dead load plus wind load, live load, dead load, notional loading, and wind load. Just check the worst possible combination, and you can use that and the result of that for your analysis. Okay, so we go in depth in that during most of our classes. Okay, just say okay here and then say okay here when we have generated that. Okay, let's say okay. So the following analysis, yes, say yes, and we have. So if we added our wind load, this is the place where we go to add our wind loading parameters, wind load calculator, and all that. Okay, so it says we have to define wind loads first before we can be able to add that. So we don't need to do that. So just say cancel. Then this place is a very important place. This region where we define our materials, the materials that we are going to be using for this structure, their properties, yeah, their physical properties. We are going to be defining them in this region. Okay. So now to define that, first of all, we are seeing that our materials here, our concrete materials and our reinforcement steel grade. So the class of concrete that are used for our different columns says 25/30. That is class 25 or 30. And here we have our reinforcement steel grade. 500 millimeter. That is 500 type 2. Okay, so that simply means that is about 510 newton per millimeter squared of characteristics tensile strength of steel. Okay, so but you have the option to change all of that as we want. So let's go to edit material to change that. So in edit material, you have default materials and foundation floor materials. Okay, so in default materials applies to every other element in your superstructure. That is from your first story to the um last story to the roof level. Okay, while the foundation material only applies to elements in your foundations like your footings, your plinth beams, and all that. That is your superstructure. Okay, so let's test for the foundation, the default material that is for superstructure. So we can see that our columns here have this class of concrete 25/30. To change that, simply click on that 25/30, and we are going to notice by the left side of this dialog the different various steel concrete grades that we have here. So we have the class 16/20, and by the right of it, we have the different properties and behavior of that class of concrete. For example, if I select this 25/30, we can see the class here. We can see the modulus of elasticity and the FCK, yeah, which is the compressive strength of that concrete, and of course there is a tensile strength of your concrete. But we already know by now that your concrete is not a good member, a good option for managing tensile forces. Okay, so that is basically for our compressive forces. Okay, so we have the FCK of our concrete here to be 25. So this class of concrete has this characteristic strength of compressive strength to be 25 newton per meter square. So we also have many other options here. We also have the unit weight here as well. You can change that if you want. But in this case, I would like to use the class of 20/25 with the compressive strength as 20 newtons per meter square. Then when I've done that, I'll simply click OK. So the same thing goes for my share walls. I would like to use the same thing for my share walls. Okay. So just make sure I select 20 over 25. Then at the bottom, you are going to see this option that says apply to all member of this material class in story. So these options, when you check these options, it automatically applies this selection or this class of concrete to every concrete member in the building. Okay, just say okay, and you're going to notice automatically the concrete beam slabs our every pretty much every concrete member. We automatically now have this 20 over 25. So the same thing goes for our steel grades. So we had the option to change the steel grade. We can see the different parameters, the tensile strength of our steel and the tensile strength of our steel. Okay, so I prefer to leave it at 500 newton per meter squared. I'm okay with that. So you have the option to change the rebar diameters, the options for our rebar diameters. Um, we are not going to be going to that right now because it has to align together with the settings that we would have made in the column parameters setting. Okay, just say okay here, then say okay. And now here we have our unit weight of member 25 newton per meter square, unit weight of blocks, coefficient of thermal expansion, and all that. So when you have now done with this setting, simply navigate to the analysis method. So you have to run a building model check of your member to ensure the connectivity of every members that you have modeled to make sure that they are well aligned with each other and there's no mistake. Okay, just like we explained in the beginning. So I've already done that. That is why I see this green check mark, which means that the building model check is done. So just click that to ensure that your building model checks are working perfectly. Okay. So before we move over to the building analysis, you can see this red X, which simply means that our analysis has not been done, or it's not, it doesn't exist. We have not done any building analysis. Okay, so we have this option that says perform eigenvalue analysis. So an eigenvalue analysis can be performed as part of the building analysis for natural frequencies and most shapes. So during this eigenvalue analysis, no load cases are actually used. So but the eigenvalue analysis results can now be used for seismic design purposes and can also be a value of wind tunnel test. Okay, so we also have this option that says here display analytical model before analysis. So the analytical model will be produced and shown before the analysis of the members when you before the design of members when you check this option. I would like to leave that unchecked. Leave the eigenvalue analysis unchecked as well. Okay, so then we have this option that says refresh connectivity of all members. Check that. Then say foundation column slash floor results for multi-block combined foundation design. So this is only required when the project will be imported by other projects for combined foundation design. So let's leave that unchecked. We don't really need that right now. Then simply click on building analysis. So the analysis process is going to take about probably a minute or more. So here you get this batch design option. So I would like to perform the column design and beam design as soon as the analysis is concluded. So I will also reselect bar and design. So just click on building analysis. There's no need to check for steel members. We didn't model any of those. Just say building analysis. So the building analysis have just started. So I would advise you not to interrupt the process. Just wait for it. Hold on until the program by itself completes the analysis and make sure that there is no errors and all that. Okay. So the analysis might have been concluded. So what is happening now is the column reinforcement designs, and after the column reinforcement designs, the beams follows through the walls, then the beams. Okay, our building analysis and design have now been successfully concluded. Okay, now we get this option that says relative story drift specify the limits. So just say okay, and now the building analysis has now been completed. Just simply say close. Okay, so this is our model and this is what it looks like. So after our analysis, in order to build the analytical model of the structure, simply go to the building analysis tab and go to post analysis option and then say display analytical model. So let's hold on a bit while it's coming up. Yeah, it's here. So here is our analytical model of the analytical model of our structure. So um this is what it looks like. Okay, so the blue this thick blue lines indicates our um um the shear walls. I mean the dark blue lines are the rigid shear walls, and then the red lines here is just um the displacement diagrams of the different members. Can you see that? Okay, so we also have these blue, just ordinary blue lines. They are just the analytical wireframe of the building. Okay, so you can explore this analytical model and check for the different um, displacement values by using the options here that we have on the menu tab over here. So in this region, this is where we get to interact with the analytical model. Okay, so you have the option to animate that. Just click on that. Um, Click this displacement to get rid of the displacement um diagram. Okay, so you can put that back. Yep, yeah, it's back. Okay, so here you have the option to filter different stories and then leave only the stories that you want to see the analytical model. So in this case, let me just check story one. So this is just the analytical wireframe and displacement of the story one. So let me uncheck all of that. I can check that off so that I can see all of them if I want. Now here we also get to show the different diagrams and the analysis result values. Okay, so you are going to explore this on your own, and during most of our trainings we go into explaining all this so that everybody can understand that. So but for want of time we need to be moving on. So here let's go back to our 3D story 3D view. Let's close up the building analysis model so that our system won't be running slow. Okay, so now let us have a visual interrogation of the structure. Let us see which members are now failing and which members now successfully pass the the design. So let's simply click on the visual interrogation and then go down to the design status and then say okay. So what you are going to notice immediately is that all members of the building successfully passed the design. Okay, so I can see a column that is failing, this column here um showing the red color, so it means that that column has failed. So you can explore that using this design status bar at the left side of your modeling screen. over here. Yeah, the left top left side of your modeling screen. So you will find this design status bar. So which simply means any member that is showing this red color simply means that member has failed. While yellow means warning, and orange is expired analysis, and for green means that members have successfully passed the design. As you can see, most of our members have now successfully passed the design. And here we also have this option that says do not design the blue color. So we don't have any member um, that is showing that color for now. And here we have the option that says not design. So you are going to notice most of our slabs, all of our slabs are showing the white color, which simply means that we are not actually designed for. Okay, so but during our advanced classes, we also show you how to run strips on slab, where to use as, where to know which slabs are going to be having hugging moments and all that. So how to provide reinforcements for those regions. Okay, so even in our advanced class, we are also going to dive deeper to in this what do we call it, in this column and beams design. So we also explore the reinforcements that are provided for the design and how to arrange it so that it will be in a very good form for, for your working drawings, for detailings and all that. So this column that is failing is one column 9. So let's go back to our plan view and let us see what we can do about that. So this is one column 9. Open the drop down arrow. Let's make the column 1 active. Yeah, one column 9, you can see is showing that red X. So what I can do is just move to the section design. Just click on the section design on the ribbon panel and hold on a bit. Yeah, we are going to get something like this. Click on interactive design and we are going to find out why that column is failing. So a moment of axial load based utilization is not utilized. MD of MSUP is given that, so this is not within the acceptable range. So I'm supposed to be explaining all this, but then again, for want of time, I'm going to be speeding ahead. So, but for the sake of emphasis, what I need to do here is either increase our reinforcement size, or I can then increase the number of reinforcement provided for this particular column. As you can see, we only have 4 numbers of H of reinforcement. That is why it's failing. So I can increase the section size. So for this case, let me just choose to increase the section size, and then let me use 300 by 300. Then go back to interactive design, and then I believe it should be passing, but it's not passing. Okay, let's do something else. Go to your column analysis. Let us find out why it's happening like that. Okay, so it's out of range. Yeah, it has now successfully passed. So it says reinforcement H12. When it shows you the reinforcement provided here, that means the column has now successfully passed. So I'm going to explain what I just did now. Many of us may not understand. Okay, just say when you have finished doing that, simply say okay. Now we are going to find out that that one column 9 has now successfully passed the design. Okay, this is it here. And when we go to a 3D view in that interactive design, okay, we are going to notice it's still showing that red color. I don't know why it's still showing that, but it has already indicated that that column passed the design, has already passed the design. Okay, so the problem is now from the software. Okay, yeah, it has now started showing that red color. Okay, yeah, the green color rather. So sometimes the software itself may be showing red for columns that have already passed the design. Okay, so that is why you need to know a lot about the manual and guiding principles um, to design of RC members so that you can even know when a column is failing on your own. So if you know how to do manual calculations, it will help you in some of these cases. Okay, so that is that. So having done this, what is remaining now for us is our substructure. Okay, so for now I'm not going to be designing the slabs. So what I will be designing right now is the pad foundation footings. Okay, now to do that, simply go to your plan view and make sure that your story 00 is active. So having your story 00 active, so anything that you are modeling about your foundation, both your pad footing, your strip footing, even if it's a wrapped foundation or a pile foundation, okay? So it has to be done on the story 00 level. So you cannot model any foundation elements on the story 1 or any other level, okay? So the story 00 level is actually the bottom of the footing area, okay? So that is that. So now to insert a pad footing to your structure, what you can simply do is select a a footing, a column, just like this one. But before we do that, I want to run us through the axial load comparison report. I mean the axial loading value report. Okay, to do that, just go to the display tab and then click on visual interrogation, and then instead of going through the visual interrogation, look for column display options and then impute axial load. And then for the load cases that we are going to impute, let's use the dead load, live load, and let's use um, ngx plus. Okay, let's use the notional dead and live load, and that should be enough. Let's just say okay, and then let's use loading combination, or let's leave that for now. Okay, let's say okay. Let's go back to our visual interrogations again. I think I would need to use that loading combination again. Let's use this combination. Okay, this one and then this one, and then say okay. So what you are going to notice is that at every column you are going to be seeing the loading combination values at the loading intensities of the axial loading that is coming on each column. Okay, so G simply means the dead load and Q is the live load, and the NGX is simply the notional dead load and notional live load NQX as well. So we have the combination 1, combination 3, 4, and 9. This usually carries the maximum amount of loading, the highest loadings. That is why I chose those combinations. But nevertheless, if you are doing your own design, you ought to look at each and every combinations to know which combination have the highest loading intensity that you are going to be using to design your columns. Now, back to adding a path fitting. So what you are going to be designing for this lecture or lesson is just the path foundation. So to do that, simply click on a column, right click, and then say insert path footing. When you have clicked on that, a dialog, the path footing design dialog is going to appear, and it will allow you to select the different geometries of the path base. Okay, yeah, it is giving us this 1200 millimeters by 1300 millimeters as the path footing um, as the base area of the path footing. Okay, so at this rebars we have the option to change the rebar diameter and rebar spacing over here. So we have this geometry. So here it shows the preview of that. So we have the um, overburden pressures at the corners of this path footing. Okay, we know that um that's where the pressures are highest at the corners. Okay, so here we have the 3D view of that as well. This is the reinforcement of that, so you can pan that just like you would navigate every other 3D view. Okay, so this is what the reinforcement looks like. So you can go to the 2D view and you can see the loading intensity as well. So I would like to change the depth of the footing. Let me do 200. Let me see what that looks like. Okay, I think I set the minimum to 400, so it can't go lower than 400, which is good for now. Okay, so moving on, having generated all these design parameters, this the length and width of our part basis. So the next thing to do is just simply say okay. So wait for it a moment and the part putting will be added to that. Yeah, it has been added. So now simply go to 3D view to view that and look at how it is here. So you can see the part foundation is also showing that green color, which simply tells you that it has also been designed and it passed the design successfully. So now let's add multiple part putting in case you missed that. So simply click on the part putting, a column, right click and then say insert part putting. Yes, okay, so the part putting um, parameters is going to be inserted, and here it says design successful. So just say okay and let it be inserted. Okay, so now you are going to repeat the same thing for the rest of the columns, but let me also show you how to design for um combined footing. Now to design for combined footing, that is a footing carrying two columns at the same time. Okay, so to do that, just two columns select two columns and right click and then say this option that says insert combined part footing. Simply click on that and then you're going to get the dialog that allows you to interact with the geometry and the design of the combined part footing. Let's wait for it. It's going to come up in a few seconds. Okay, yeah, so we have that. So the length and width of that lx over ly is 1800 millimeters by 2800 millimeters. It also says design successful. Okay, so it's provided here 600 millimeters as the depth of part putting. That could be a lot, but there is a way that we can correct that and interact with all those to make sure everything aligns as we would want it and still successfully pass the design. So we can explore the 3D view to see how the reinforcement placing looks like. Okay, this is what it looks like. So this is the combined part putting analytical, 3D rebar model. Okay, so just simply say okay, and it will be updated here in real time. So let's simply go to our 3D view. Let's see what it looks like. So you can see our individual part putting, and we can also see our um combined part putting. So this part putting is very you need to know how to design that. Okay, so that where you have areas where you have part puttings that are clashing with each other, you can simply use the option of combining the part putting. Okay, so that is that for this class. So we have now successfully treated pre-analysis, building analysis, design, and interactive design. So we have not treated the interactive design check of everything. We didn't also treat the design reports and detailing. And the conclusion here is that you should try as much as possible to engage yourself in our advanced classes. So in these advanced classes, you are going to be learning a lot. Okay, so that is that for our our lesson. So here we have a pedestrian bridge that was modeled and designed in ProtaStructure, and here we have a foot overhead bridge sitting on Pile Foundation. Okay, so that is that for today's classes. So I wish you the best of luck and thank you for joining this class and God bless you all. Thank you very much. Bye bye.